Hi student, how are you? In this video we are trying to know about the Hooke's law. Now what is Hooke's law? Hooke's law, remember one thing, this is about on the spring. Usually like when we compress the spring or split the spring or apply the spring apply the force on the spring, so there is a work done. So let's move to the next page. There are some diagram you can understand easily and you will understand what is Hooke's law. Okay. Here the amount of expansion is directly proportional to the applied force. Like here, look at, there are three different position of the spring. Like this is the original position when the force is 0, so the displacement is also 0. Mean when we do not apply the force, so the spring is on the normal position. And the next case, when we apply the force on the spring, so there is produced some displacement in the spring. In the third one, let's see if we double the force, so the displacement is also double. This means that force is directly proportional to the displacement. Like in next one, like how can we finish the proportionality here? So we can finish the proportionality kx, mean it will get this k is the spring constant. And it depend on the material of the spring, like what types of spring is that, like the steel spring, iron spring, plastic spring. Every spring has its own spring constant value. You will see in the question if we will solve the simple example which is related to the Hooke's law. Okay, let's again see what is Hooke's law. This is the amount of expansion. Expansion mean like when we apply the force on the spring, so this is called expansion. Like if we apply the force on the spring and we expand, sometimes we compress and sometimes we expand, so this is called expansion. So if we increase the force, so the displacement covered by the spring is also increased, but under the elastic limit. Mean like sometimes if do not apply the much more force on the spring, like sometime spring like if we increase the more force on the spring, so sometime the spring will not become the spring. So okay, like if by x, so this is the formula simple. This is the formula, F is equal to k into x. This is the Hooke's law formula. It depends the spring constant, like spring value, and this is the displacement in force. F mean what? Force. Okay, let's move to the next page. Okay, the proportionality can be written in the form like sometime we have compressed the spring and sometime we will expand the spring. This is called expand, but this is called compress. Okay, for there are two types of force. One is spring force and the other one is external force. Like if we apply the force in this case, this F gives us the external force. External force will be positive. Why? Because it moving on the positive direction. Mean this is positive side if we move this side, and this is negative side. But the spring force is negative. Why? If we apply the force on the spring, so the applied force move toward the positive direction, mean this direction, but the spring's force is opposite to the applied force. It will try to move back the spring toward the negative direction. It is against. So this is called what? Spring force and applied force. Okay, in the another diagram, if you see, here is the compress of the spring. So now what is the compress of the spring? Like if we apply the force, external force here, like in this direction, so the applied force will be in which direction? Toward the negative direction, but the spring force is try to pull back the spring in toward positive direction. So F of S denote the spring force and F external denote the applied force. Okay, one thing remember, sometimes the spring force is negative and sometimes the spring force is also positive, you will see the spring, so it is compressed, the spring. In compressed, the spring force is positive, and in expansion the spring force is negative. Okay, the spring force always act toward the equilibrium position. One thing remember, the spring force always try to move back the spring to the equilibrium or balance position. K is called the spring constant. I told you here the K value denote the spring constant. Like every spring has its own constant value. It depends on the material of the spring. Like I told you what types of material use in the spring. So it is the plastic spring, it is the iron spring, it is the steel spring, or it is the copper, or what types of material. And the unit of K is equal to Newton divided by meter, and it is called spring constant. Okay, let's move to the another page. In this page we are going to solve a simple example which is related to Hooke's law. Okay, here the value of the spring constant is given, which is equal to 200 Newton meter. Like this is the original position of the spring when the some mass is attached to the spring, so it moved downward, so a 30 centimeter it moved downward. So they asked that how what is the mass of the block of the system, like we will find the mass. Okay, one thing remember, it is moved downward, so it is weight, and weight is equal to mg, and it is also equal to force. So we know that using the Hooke's law, in this case, like weight is equal to mg and it is equal to force. Like the Hooke's law is equal to k into x, mean spring constant and displacement. So here I can also write mg instead of force, which is equal to k into x, just putting the value. M multiplied g value is constant, which is equal to 10 Newton per kilogram, is equal to k. K is 200 Newton divided by meter and multiplied by 30 centimeter is equal to 0.3 meter. Yes, this is equal to 0.3 meter. So meter will be cancelled with meter and Newton will be cancelled with Newton. So mass now is equal to 200 multiplied by 0.3. 200 multiplied by 0.3, this is equal to 60. And here multiplied by 10 divided by kg. So now if we divide and multiply the values, so it will become 6 kg. So the mass of the block is this one is equal to 6 kilogram. Okay, so this is the Hooke's law question. So if you have any types of question related to the Hooke's law, and here one thing remember why they put the Hooke's law in the work energy chapter, because if we apply the force, so the force, and because of the distance, it is here some work is done, and because of this work done, so they put the Hooke's law in this chapter, which is done on the spring. So thank you so much, dear student. If you have any questions, so you can ask in your comment. Thank you, dear student.